Hey, welcome everybody. Alright, we begin our investigation into the graphs of basic trig functions already, y equals sine x, y equals cosine x, and y equals tangent x. What we're going to do in this video is we're going to examine what happens when you start translating those different graphs. So we're going to graph translations of y equals sine x, y equals cosine x, and y equals tangent x. Now, to begin the discussion here, what I want to do is remind you of what we learned back in Chapter 1 in terms of how you manipulate the equation of a function in order to translate it either horizontally or vertically. So consider a function f of x, and we'll say that's our parent function. Well, remember the way that you translated f of x horizontally is you either added or subtracted a value from the input, from the x, such as this. All right, if you have something in the form f of x minus k, that's a horizontal translation of the function f of x. And remember, if you use the opposite sign here, so if you have a negative number here, it implies that you have a translation to the right. If you have a positive number there, it implies you have a translation to the left. I'll come back and cement that little bit of information into your head in just a moment. Now, for vertical translations, rather than adding or subtracting a constant value from the input, what you do is you subtract or add a constant value from the output of the function. And so if you had an equation in the form y equals f of x, and then you add k after you evaluate f of x, then you get a vertical translation. And positive means up, negative means down. Now, we're trying to translate y equals sine x or y equals cosine x or y equals tangent x. So let me give you some examples of equations that would be horizontal translations and then that would be vertical translations, and then we'll get to the graphing of such functions. For instance, let's suppose we had the equation y equals sine of x plus pi over 4. All right, well, you can see the addition here is happening to the input. We're adding pi over 4, and then we're evaluating the sign of whatever's there. And so that's a horizontal translation since it's been added to the input. And what I was saying earlier is that you kind of use the opposite sign of what you have here in order to determine the direction. Since that's a plus pi over 4, turns out this is a translation to the left by pi over 4 units. Whereas, let's say I had something like y is equal to the cosine of x minus 2 pi over 3, well, again, we have the addition or subtraction happening from the input value, so it's a horizontal translation. And since it's minus, that means we're actually going to the right by 2 pi over 3 units. Now, an example of a vertical translation involving a trig function would be this. Let's suppose we had the equation y is equal to the tangent of x plus 6. All right, now it's going to be important that you notice that whenever we're adding to the input value, you always need to put what you're adding in parentheses. If I don't see parentheses here, that's not x plus 6 and then tangent. It's the tangent of x, and then that output gets 6 added to it. And so really all this is going to be doing is shifting the graph 6 units up. All right, so now that I've reminded you of how horizontal and vertical translations work with equations of functions, let's go ahead and graph some translations of some trigonometric functions. I'm going to do one graph of a translation of a cosine, then a sine, and then a tangent so that you can kind of see each of them. And in addition to teaching you how you do the translations, I'm going to remind you of just the simple way of going ahead and graphing a cosine or a sine or a tangent function. Maybe make it a little bit simpler even than what we've discussed in previous videos. All right, we're going to be sketching in this example the graph of y equals the cosine of x plus pi over 4. And based on what we've talked about for the last minute or so, you know that that means that we have the graph of y equals cosine x shifted to the left pi over 4 units. All right, now to the actual graphing. What I'm going to do here to teach you how to graph this translation is I'm going to go ahead and graph the parent function y equals cosine of x, and then show you how the actual shifting works. And it turns out to be very simple if you think of it in the terms that I'm going to be showing to you. And in order to really get that across to you, I want to remind you of the pattern that happens whenever you're graphing a cosine function. It's really simple to graph a cosine function if you think about graphing it in quarters 3/4 of the way through its period. Now, the typical period, if you'll recall, for a cosine function is between 0 and 2 pi. We say the period is 2 pi units, but the length of one cycle, I mean to say, is typically between 0 and 2 pi. And think about in terms of maximum and minimum and medium values, which one of those you would get at each point on the unit circle. Remember, cosine has its largest value at 0 radians. So you start off a cosine graph at its maximum value of 1. And then when you've gone 1/4 of the way through its cycle, the cosine becomes 0, which is really the middle value, right? And then by the time you've gone halfway through the cycle, the cosine has reached its minimum value of -1. When you've gone 3/4 of the way through the cycle, it's at the middle value again, 0. And then finally, when you complete the cycle, you're back to a maximum value. So cosine goes from maximum to middle to minimum to middle to maximum. Now, how does that play out on the actual graph? All right, we'll watch this. All right, so again, thinking about the cycle going from 0 to 2 pi, I said you're going to start off a cosine at its maximum value, which is 1. You've got 1/4 of the way at pi over 2, and that's when you've reached your middle value, or your intercept, as I called it in the previous video. And then once you've gone halfway through the cycle, once you've reached pi radians, you're at -1. Then you're back to the middle value at 3 pi over 2. You're back to the maximum value at 2 pi. And I'll go and connect those points. And then the process of making the rest of the graph is simply alternating from maximum to middle to minimum to middle to maximum. And we're going to do that backwards because we're trying to graph this function from -2 pi to +2 pi. So we still need to do the -2 pi to 0 part. Well, so going backwards, then we're going to have, we got the maximum, then we'll have a middle, a minimum, a middle, and a maximum value. So there's the middle, there's the minimum, there's the middle, there's the maximum, and I'll connect them, and we've got our graph of y equals cosine x. Now remember, that's the parent function. What we're going to do now is graph a translation of that, the cosine of x plus pi over 4. And this was a shift of pi over 4 units left. Now I'll make this graph in orange. And simply all we're going to do is we're going to translate all the units that we have here, all the points that we have on our graph already, pi over 4 units to the left. Okay? Now if this is 0 and this is -pi over 2, isn't this -pi over 4 right here? Now here's kind of the point. We're going to have our maximum value is going to get shifted to the left by 5 over 4 units, and then our middle value will be shifted the same, and every value will be shifted simply pi over 4 units to the left. Now as I draw this part of the graph, I just want to make note of the fact that, remember, our function is supposed to be shown between -2 pi and pi. So I'm not actually going to go all the way back to this maximum value over here just because that's smaller than -2 pi. I'm going to stop right here. All right, but that's the first part of our graph. And just go ahead and shift all the other units, or all the other points, pi over 4 units to the left as well. Like so, and then let's go ahead and connect them. Now this time I didn't quite go all the way to 2 pi, so what I'm going to do is think about, well, what would be the next point that I could graph here. We finished at a maximum value, so the next thing would be a middle value, and that would be pi over 2 units away, wouldn't it, right here? Now that's a little too far, that's a little bit bigger than 2 pi, but what I can do then is I can draw as much of it towards the graph towards that point as I can before I get, or until I get to 2 pi. So what's in orange is a graph of y equals cosine of x plus pi over 4. All right, great. You've seen how to translate horizontally. Now let's go ahead and look at the graph of a sine function and a translation of it. And you're going to see in this case we're going to have both a horizontal translation and we're going to have a vertical translation because we have values being added or subtracted from both the inputs and the outputs in this function. Now I'm going to graph the parent function again as I did with the cosine of x, and then we'll talk about how you do the shifting of things here. Now with a sine function, you have a slightly different pattern. You're still alternating between maximum and medium values and minimum values, but where you start is a little bit different. Because remember, with the sine, when you're at 0, you start at the middle value. You don't start at the maximum value like you do cosine. Now, by the time you've gone 1/4 of the way through the cycle, you're at a maximum value, which is 1, of course. Then you've gone halfway through the cycle, you're back to the middle value, or 0. And then 3/4 of the way, you're at the minimum value of -1. And then you complete the cycle when you arrive back at a middle value again for the third time, it turns out in this case. And that's if you're going from 0 to 2 pi. Now let me graph that much of our sine function. I'll again make the parent function here in green. And it'll start at a middle value, half or a quarter of the way to 2 pi, it'll get to its maximum. Then after the next quarter, it'll go medium, then minimum, and then it finishes up at a middle value again. So there's the from 0 to 2 pi portion. There's one cycle of our sine graph. And then let's go backwards. All right, we're at middle. We were working our way down right here. So the next thing going pi over 2 units to the left is going to be a minimum, then medium, then maximum, then medium again. And there's the rest of the graph from -2 pi to 2 pi for the parent function y equals sine x. Now, I hope you recognize that for our function, it's going to be a shift of pi over 3 units right. And then a shift of 1 unit up. All right, now let me actually talk about how you handle the vertical translation part of this, and then we'll get to the horizontal part of the translation, which we've kind of discussed in a previous example, right? With the vertical part of the translation, we'd be shifting everything up. So instead of the values cycling between -1 at a minimum and +1 at a maximum and being centered around 0, what's going to happen is that they're now going to be centered around 1, and they're going to fluctuate between 0 and +2. The amplitude hasn't changed. The amplitude is still 1. You go 1 unit above the median value and 1 unit below the median value. Now, just to help me make the graph a little bit more simple to draw, what I'm going to do is go ahead and make a horizontal line that's going to represent the middle value, so to speak. Before, we've been using the x-axis as our middle value, but now let's use the line y equals 1 since we're shifting that 1 unit up. And that's what this is going to represent right here. If I ever get it to actually draw the way I want it to. There we go. Then we can talk about how the other values shift horizontally. Now we're going pi over 3 units, and you're going to notice my intervals here on my graph are going by pi over 4, because this will be pi over 4 right here, and then this is 2 pi over 4, 3 pi over 4, 4 pi over 4, and so on. Well, pi over 3 is between pi over 4 and pi over 2. Not quite halfway between, but let's say it's right around there. Okay, now we're shifting all our values that many units to the right, but we're also shifting them up 1 unit. So this middle value, which is what we're going to have first, is going to be shifted pi over 3 units to the right, and then up here, this is where the first point in our translation is going to go. And then let's make sure we get the pattern right, and then we'll just go on cruise control kind of after this. Now we need to shift the maximum value that we started with, this one, by pi over 3 units to the right. So that's going to be maybe about 1.5 grid lines is what we're saying here, right? So and then we're going to shift that up as well, 1 unit. So to here. And the way we've got it set up right here is that every 2 vertical grid lines is 1/4 of your cycle, correct? So here's us going 1/4 of the way, and we went from medium to maximum. Then another 1/4 of the way should get us back to the medium value, and so forth. That's how I'm going to make the rest of this graph. So here I have a middle value, and then I would have a minimum value, like so. And then going backwards, I'm at the middle value, working my way down, so I'll have a minimum value here, and then a middle value, a maximum, a middle, and then a minimum again. And let's connect those and only draw the portions between negative 2 pi and positive 2 pi. Now this is what the left half of that would look like. And then this is what the right half of that would look like. Alright, there you go. That's our translated function. One more graph because I want to show you how you do this with tangent functions as well. Then we'll be done with this video. Alright, you see we've got another kind of double translation going on. We've got a vertical and a horizontal translation here. Let me finish this number that didn't show up so well. That's a -4, we'll say. This is a shift 2 pi over 3 units to the right and 4 units down. Alright, now let's graph the parent function, and then we'll go on to the graph of the translated function. So whenever we have the parent function, remember a complete cycle happens between negative pi over 2 and positive pi over 2. The period of a tangent function is only pi units, correct? You can actually get 2 full cycles between 0 and 2 pi. So, well, that'll change what is 1/4 of the way and so forth here in a moment. When you begin that negative pi over 2 to pi over 2 cycle, remember at this point the tangent is undefined, and so you get a vertical asymptote there. But I'm just going to say it's undefined. Alright, now you also get that at the other end point here, when you've gone all the way through the cycle. When you've gone halfway through the cycle, you have your middle value, where the tangent is equal to 0. But remember, you don't get a maximum or a minimum value with the tangent function because the range is from negative infinity to positive infinity. However, there's still a pattern that happens when you go 1/4 of the way through the cycle and when you've gone 3/4 of the way through the cycle. You've gone 1/4 of the way through the cycle when you get to negative pi over 4 here, and that tangent is -1. So 1/4 of the way through, you get to -1, or 1 less than your middle value is what I ought to say. And then when you've gone 3/4 of the way through the cycle, that's where tangent is equal to +1. And so you get a value that is 1 more than whatever your middle value is. And you'll see what I mean by more than whatever your middle value is momentarily. But let's go and graph the tangent function. Let's go and graph our vertical asymptotes. Everywhere the function is undefined, and that we said it starts at negative pi over 2 and positive pi over 2, and really every pi radians, right? Every half revolution around the circle, you get another horizontal or vertical asymptote. So at 3 pi over 2, you would have one, and then at 5 pi over 2, but that's out of the range of values we're considering anyway. And then going backwards, negative pi over 2 to negative 3 pi over 2, that's going to give us another vertical asymptote. And each cycle we're going to have is going to fit between a pair of vertical asymptotes. Now the way I've divided up my intervals here, I've made it so that it's easy to show what's 1/4 of the way, what's half of the way, what's 3/4 of the way through the cycle, okay? Let's look between negative pi over 2 and positive pi over 2. When you've got 1/4 of the way through the cycle, you would be right here, and that's supposed to give us 1 unit less than our middle value of -1, or of 0, so that would give us a point here. And then halfway through that cycle, you're supposed to get 0. 3/4 of the way through that cycle, you get +1. Now those actually line up in a straight line, but you know that's not the way the graph of a tangent function is supposed to look. I just want you to make kind of a curve through those points that looks like what the branch of a tangent function ought to resemble, and that would be this shape right here. And then for between every pair of asymptotes, you're going to do the same thing. 1/4 of the way, you've got your one lower than the middle. Halfway, you've got your middle. 3/4 of the way, you've got your one higher than the middle, and then you connect them as such. Okay, now for the next one, we're not going to have an entire cycle. We just need to finish up at 2 pi, which would be, well, halfway through the next cycle. So all we're going to do is we're going to show that 1/4 of the way through the next cycle, we've got our one lower than the middle. Then we're going to finish at the middle. We'll only get that part of the graph. And then I'll kind of repeat for these last two sections of the graph that we haven't touched yet. All right, and hopefully you see why I did just a half a cycle there between -2 pi and -3 pi over 2. Okay, now for the translated version of the function. Let me take care of the vertical translation first. You can see that we're shifting 4 units down, which means our central value is going to shift from 0 down to -4. And I'm just going to draw a dotted line down here to show where that central value is located. Then for the horizontal translation, it's going to be easiest for us if we'll go ahead and just shift the vertical asymptotes, because then we can just fit any cycle that we want to draw in between the vertical asymptotes. Now to aid in that translation, because we got kind of a funny number here to translate by, I wrote this pair of inequalities at the bottom. I think you agree that 8 pi over 12 is between 6 pi over 12 and 9 pi over 12. And the reason why I bring that up is because we're shifting 2 pi over 3 units, and 8 pi over 12 is equivalent with 2 pi over 3. And then 6 pi over 12 is equivalent with pi over 2. 9 pi over 12 is equivalent to 3 pi over 4. And on our graph, for instance, if this is pi over 2, this is 3 pi over 4 since that's pi, right? So my point being that 2 pi over 3 units is a little bit less than 3 bars, right? Because if you go 0, pi over 4, pi over 2, and then here's 2 pi over 3, almost 3 units over. So let's say I want to shift then this vertical asymptote. I'm going to shift it over 1, 2, and almost 3 vertical lines on my grid. Right there. And once I've got that, then what I can do is I can just keep copying it every 4 lines, because remember the period of a tangent function is pi, and every 4 grid lines here is pi units as well. So the next vertical asymptote would be here. See, here's 1, 2, 3, 4 grid lines over, so that's pi units. And then I'll keep copying 4 grid lines to the right and then to the left of each of these asymptotes to translate the rest of them. And then let's just put 2 vertical asymptotes and look between them. How about let's look between these two? We know that halfway between them is supposed to be our middle value, and remember we're centering it on that one line that I had right here, this horizontal line. So that's where our middle value goes, and in the middle of every cycle we can go ahead and just put a middle value. And then when you're a fourth of the way through the cycle, you know you're one lower than that. So that could be right here, right there, right there, right there. And when you're 3/4 of the way through the cycle, you know you're 1 unit above the central value. So that then can be here, 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 and there as well. Now, for this last little bit over here, it looks like we might be able to fit a 1/4 of the way thing through there, so I'm going to put that dot. Then let's go ahead and make the rest of the shape. We can say this is a branch, this is a branch, and so on. All right, now it's challenging, but I think you can see the basic idea of how you go ahead and graph a translation of a sine or a cosine or a tangent function. All right, thanks for watching. We'll work on this more in class to hopefully make it even easier for you. See you later.